Little red. Here it is. I think we're ready, gentlemen. Hey, everybody. Welcome aboard. Once again, we gather here every week on a Monday morning. Big bad vlog for Santa Barbara, California's longtime telescope and astronomy club, the Santa Barbara Astronomical Unit. It's heard and seen Mondays, 11 a.m. for 1 hour. And we call it the SBAU Astro Hour. I'm your host, Ron Herron, Vice President of the club, somehow. Introduce you to the rest of the board, to the outreach guy, the incredible newsletter editor, and our president. Fantastic members in a moment. Meantime, follow along on YouTube. We just joined them. Be ready to comment or ask questions below, because I got to tell you, these are some of the brightest, most knowledgeable minds in town, if not in the West Coast. Come join our club. We meet up at the Museum of Natural History up behind the museum, the Mission, on Mission Canyon, first Friday of the month, usually with a planetarium program for half an hour before the meeting starts. Second Saturday, which we just went through, a little chilly, but we were out there for the star party. It's also free. We missed our outreach guy. He'll be back with his meteorite next month. Find out all about us by going on the internet at sbau.org. Okay, everybody? Incidentally, this coming March 1st, will be the fourth year of broadcasting this program.
Whoa.
We started in the first Monday of, or the first week of March 2021.
Wow, that's been that long? Holy cow.
156 programs. This is number 156 episode. Let's meet the gang, shall we? And then we'll do some silly cartoons. Here's our president, Jerry Wilson.
Speaking of silly, yeah.
Yep, he has an excuse for not being at our star parties. Number one, he freezes his garbanzos off. And number two, he edits and puts together these talking points for the Astro Hour. His wife is Pat Forgy, and it's now 7 years being reelected. Chuck McPartland looks like he's recovering, our outreach man. He's missed, of course, but he's out there a lot. In fact, you picked up what you got over the weekend, didn't you, from a recent outreach event?
I'm not sure. It hit me in the middle of an outreach at a school science night, but usually there's an incubation period. So I might have gotten it when we went shopping or went out to dinner a couple of days before.
Yep. You never know.
Yeah.
But you raced and got the COVID test because it was respiratory, and you say you're down to 100 degrees now Fahrenheit.
Oh, I'm just kidding. I was taking COVID tests every day and it was negative. So this is, I think, influenza because I was aching all over.
All right.
And temperature was 103 for a couple of days, but now it's actually, I'm down to 99.6. So
Excellent.
Well, I think Tim Crawford and I can tell you we missed that incredible 5-pound Argentinian meteorite. I brought some of the dust from under my couch and tried to do the same spiel, but it didn't work.
No, that's comet dust. See, you got to tell them it's comet dust.
Well, it's older than dirt. I'll
Yeah.
tell you right now.
Right, Ron, I always say that to people at star parties, I said, when I don't know something, I use the famous 6 words, I don't know, let's ask Chuck. And this last Saturday night, I said, I'm in trouble. I can't use the famous words. Who am I going to ask now?
You guys can just point out, point at yourself and say, here's Stardust.
That's probably true. But he endured the cold like I did. I was greeting the folks, and we see the top head of Mr. Tim Crawford there, longtime enthusiast and a participant, I think, on the Tuesday workshop every so often.
Yeah.
Oh, yeah.
And he is, let's see, married to Karen, whom I'm not sure I've even met. I think I probably have. Do you bring her to these things?
We met her at a Christmas party one year.
All right. Well, outreach coordinator, Mr. Chuck McPartland is married to Pat McPartland, who is our merchandise manager and our new treasurer and doing a bang-up embezzling job, let me tell you right now. And there is, laughing on the upper right of my screen, Mr. Bruce Murdoch, who's married to Bonnie, longtime supporter, telescope star, enthusiast, happens to be also president of the Santa Barbara Theater Organ Society, which may not be as active as we are, but that's okay. We love him anyway. And the editor of our newsletter is on screen, Tom Whittemore. He's going to explain to us how he can get away with getting on with us without glasses. The only one that's not wearing spectacles. Former science instructor at Westmont College. His wife is Maureen. And now that you've met everybody, Let me tell you what we're going to talk about. Oh my God, this is incredible weekend. We're always checking the moon. It's going from new moon to first quarter this week. There are at least 5 comets out there, some with Chinese names. I think one with a Japanese name. We can find them. We have a Valentine's Day special, an Astro get together in 2 days, the Heart and Soul Nebula, what you're going to want to mail your sweetheart. Um, let's see. Rise super early and check out the pre-dawn teapot asterism, everybody. It's in Sagittarius, along with our 2 closest planets. Find out where they are. And get this, a big solar flare potential. This is scary. There's a sunspot the size of 15 Earths on old Sol ready to blow, if it hasn't already. However, we're going to have some sillies first. These are the forwarded silly science cartoons from President Jerry. If I can match up what I've written down. Oh, is this the crashed? Yeah, okay. They've crashed into the earth, and one alien says to the other, "Can't believe it. One lousy little bee gets inside and you just freak out." That has happened to all of us. How in the world did they get a bee? And oh, here's another one. No, which one is this one? Oh, it's got the Christian Jesus fish, the fisherman's fish on the side, but it has 4 eyes. It's a little different on their planet. Love these space alien takes. Oh, speaking of aliens, here's a green guy landing and doing his Margaret Mead number for anthropology. Let me get this straight. He says the ape, everything on the planet was working just fine until your cousins got uppity. How do we meet these cousins? Take me to their leader.
We are the cousins.
Yeah, that's right.
You are the cousin.
Yeah, that's it. We are. Cousins are us. Okay, these are robots building robots, an AI assembly line, couple scientists, manufacturers strolling down the factory. Guy says to the other, sometimes I ask myself, where will it ever end? I assume that's what's happening. Robots are building robots.
This is supposed to be the end, the end point where humanity is in trouble, when robots are automatically producing other robots.
Okay, got it. Okay, here's
I like this one.
the boy at the blackboard. A couple of lazy 8s, which signify, of course, infinity together, add up if you make a formula out of it to a lazy 16. That works for me. Damn right. Who do you
The next time that question gets posed to me, I'm going to use this. I think it's neat.
We'll find out from Chuck where 8 came from to signify. Here we go. Another name for the periodic table is the Atom family. We'll see some new elements on there. Gomez and Morticia. And here's another, this one I like one. Another crashed UFO. Vandalized. It's not really crashed. They landed okay. A couple extraterrestrials took a stroll and came back, and the guy says to the other, oh my God, isn't this just great? I told you this planet was in a sketchy neighborhood.
Yeah, they're flying saucers up on blocks.
I know I've lost its wheels. Probably the catalytic converter is gone. They open the engine. They'll never get out of here. Broken canopy. This one I don't. Oh, yes, I do. This would be.
Oh, yeah. I like this.
Okay, now just sleep normally wearing that sleep apnea device. That's why I don't do sleep apnea therapy. I'm sorry. It doesn't work for me either. It's a little like getting in the dentist chair and they get your mouth open, gets in there, and then he asks you, oh, so how's things going?
Oh, yeah.
Similar. Okay, that gets us in the mood to get frivolous about sunspots and other stuff that you work on Saturday night. We miss you at the Star Party, but we got to have this program. It keeps going. We're building, aren't we? We're getting more people to watch. One guy at Big Bear sent us a notice a couple of weeks ago, according to Chuck, I think. All right, in the night sky we go. What's on tap here, Mr. President?
Now we're just past new moon, and I put on my planetarium software, the Sky X. Doesn't quite display as well as the Sky 6 in my view. But anyway, enough of that. I had to put a cursor in for the moon because the moon was too faint in the way they display it. But the moon is in the very early evening now, down near Neptune. And it's just a few days old.
That's the view we
and
get.
this shows, this is an app. I keep trying to get rid of this bar down here, and it goes away after a few minutes. But then when you clip it to print the screen, it pops back. So you can't, I couldn't uncapture it. But it shows the moon as we can see it now tonight, with Marcrisium starting to show over here on the side. Very nice shadows along the edge. And
I
this
think
one,
that was for yesterday, because the times are in UTC usually.
yeah.
Yeah.
Okay.
Last night,
Oh,
Maury Creasy
Yeah, it
was
says
put
12
in view.
February 2022 UT.
Yeah.
But new moon's on the right side every month, and old moon is on the left side, right? Going out.
At the beginning, but it doesn't matter for right and left because the scope will turn it around either way, depending on how many diagonals or mirrors you have in your scope.
Well, if you zero in on what we're looking at right now, can you see stuff in the darkness, the black?
Oh yeah, you can.
Oh, yeah. With the earth
Really?
shine.
Yeah.
Mhm.
Well, you can't with a naked eye.
Oh, shut up.
There was nice moon. There was nice earth shine last night. I mean,
Yes.
you see quite a
Yes.
bit.
The old
Yeah,
phrase
earth
for
shine.
that is the new moon and the old moon, or the old moon and the new moon's arms.
Please leave a message. Be sure to include your phone number.
Let me turn the audio. Oh, quit it. What happened now?
Okay.
Here's this message.
Yeah.
This is not a soliciting call. This is
High
a call.
tech. Yeah, these are experts in technology on the screen right now.
So this is the moon, and here's a time puzzle. This wasn't in what I sent out. I found this later. This is on the morning of February 10. It's in the evening in Queensland, Australia.
Hmm.
So
Really?
that means, and he didn't say in his picture, he posted it on Facebook, Kevin Parker, and he said that yesterday evening, and I found it yesterday. And so yesterday evening, I believe, is the 10th. It's about right for that. But of course, we won't see that, or didn't see that here, because this is daytime for us and it's early night for him, early evening. But it's a very nice look, and you can just barely make out features on the dark side of the moon.
Yeah.
He's got a good balance of exposure.
Yeah. This is the time of the year, Jerry, when you get close to the equinox, that the moon makes a smile. So we saw the smile on Saturday. It was a really small moon. And then last night I got it in the telescope. It was really, really, really pretty.
But the picture you just showed us, Mr. President, had the smile, if you will, the crescent on the right side. This is on the left side.
This is not a photograph. This is a
depiction, graphic.
Yeah, it's a map.
Okay.
Graphic.
And Ron, that was Southern Hemisphere, that picture. So things look reversed like that because you're looking in the other direction, basically.
Mm-hmm.
I wouldn't reverse like up and down. It's right or left. They wouldn't. It doesn't reverse.
No, when you go down to this shocked me when I went down to Australia, but it's logical. Every constellation down there is upside down, including the moon.
Yeah.
Orion's got his sword sticking straight up. So
their early crescent is on the left and not the right.
that's part of the puzzle. I think so.
I think it'd be the same constellations, just in a different part of the sky.
Yeah, when I looked at this, I thought the guy's conning me. This is actually the old crescent moon, the waning crescent. But then I realized he's in Queensland, and it is the waxing, the waxing crescent.
Here, Ron, the ecliptic is to the south. So when you look out, you're facing the south. But when you're there, the ecliptic is towards your north. And so you're looking the other way. So you've turned around. So that's why things get the weird flips.
Well, then tell me this. Up in the Arctic Circle, you see the moon 24/7, don't you?
No.
It just goes up and down like the sun does in the summer months, doesn't it?
No, it's tilted relative to the plane of the ecliptic by something like 5-6 degrees. So it'll be under.
Oh, it would go below okay, but the sun doesn't. They get 24-hour sun in summer.
The sun follows the ecliptic too.
Yeah.
Right.
They get 24 hours of darkness 6 months later, Ron. So it's not like the sun is always going around their horizon.
I know that, but I'm
rotation of the
talking.
Earth just carries it so that the apparent motion of the sun is around the horizon for a given day.
Picture this thing. Picture this. You've got a globe of the Earth, and you got a little stick figure that represents you, and you're standing in the northern hemisphere, so your head is up. Now you move down to the southern hemisphere, and your feet are attached to Earth, but your head is facing down, so the whole world looks upside down to you.
Yeah.
Well, that was in a cartoon, but it's not really that way. And
No,
Yes,
it is.
it is.
It is
Yes, it
really
is.
that way. It is really that way.
Relative to the stars.
Right.
Just an aside here, last Saturday night, we had a couple asking questions about the moon, when it would be up and everything. And anyway, I went to Sean Kelly to ask him, the moon is relatively low in some months and high in others. And I said, I think there's some kind of relationship to the ecliptic, but I'm not sure. And he started giving a fantastic explanation. And I got customers, so I had to leave. So I missed it. But he was right in the midst of saying that. He said, it's not as easy as you think it is. And then he started going into all the explanation. But sometime we may want to revisit that. It's a good topic.
Well, I once figured out that the moon rises high in the winter, higher than it does in the summer, and it's just the opposite for the sun. Wouldn't you?
You're talking about the new moon versus the sun, yes.
Or the full moon, yeah.
Full moon.
Full moon.
Excuse me. I was thinking of the full moon, but I said the new moon.
Okay.
Okay.
Fantastic. All right. Where are we here?
This is a picture of a very prominent feature that's just come in view, the crater Langrenus. It's about 85 miles wide, and this picture was taken from Apollo 8.
Okay.
That looks a lot like Copernicus, doesn't it? I mean, same.
Yeah, it sure does. Yeah. Especially the central region. Yeah.
The little after blip.
This is not only an example of a crater with a central peak, but terraced walls. There's up to 7 layers of terraces from the rim down to the bottom. So the thing slumped down in stages. Okay. Now, what we've got here is there are 5 comets in the sky right now. None of them are naked eye comets. But
you want them named, Mr. President, or you want to name them?
Did I make
2P Suchinshan? Well, we got 2 Suchinshans and a 144P Kushida C2021 8-3 Pan Stars. And
S3.
Yeah, and a Brooks and a 2023 and something called Atlas.
Yeah, Tushinshan Atlas. So these are all available to people with moderate telescopes. The last one, Sushinshan Atlas, is going to be at best viewed in September of this year. But they are all visible now. The first one, Comet 62P Sushinshan, is around 9th magnitude right now. And as you can see from this diagram of its future path and present path, this is mostly January. But down here, February 10, and we're just a little beyond that at February 12th right here. And it's going through the Virgo cluster of galaxies. So that's a very good region just to look around for, even if you can't find the comet.
You'll find something fuzzy.
Yeah. Now this is M49 in what is it?
Elliptical?
Yeah, that's an elliptical galaxy. This is another elliptical galaxy. This is M59. This is M58. These are ones that Sky and Telescope has had, or Astronomy Magazine has had as features to look at when you go by. And then, of course, this galaxy, M87, is the one that we got the first ever actual image of a black hole in the galaxy at the core. And you can see a jet coming out here from it.
Oh, wow.
Yeah.
So these are...
you can see that in a 20-inch, Jerry.
Yeah. But you can see the galaxy is there. You can see that in like a 10 or 12 inch.
Sure.
Or even lower.
Old man Messier locked in on a lot of distant galaxies, eh?
With a 3-inch scope. So
Yeah.
Yeah.
It's
Jeez.
also very odd that the number of things that he did not put in his.
Yeah, like double cluster.
Yeah, that's one. Yeah,
That's where the NGC guy came in.
yeah, Herschel.
they were sort of contemporaneous, but yeah.
Mhm.
Huh.
This is let's see, we did Sushinsen. So this is 144p Kushida.
Mhm.
It is currently it's not marked specifically here on this, but it is just south of Uranus. And during the next month, it's going to move over here through the Hyades. This part of Taurus is a very large and prominent open cluster called the Hyades.
Mhm.
Huh. I love seeing Taurus on the screen. That's my sign.
Yeah, Melot is a Melot object.
And this is and this is Aldebaran in the bright red eye of Taurus.
Mhm.
And this is a sky chart, a star chart, as many of us have, a star chart rendition of the Hyades cluster. And in this picture, how bright the star is, it gets a bigger black dot. And the black dot is scaled down here for magnitude.
In 1647 is beautiful on a wide field scope.
This one up here.
Guy,
Yes.
yeah, it's an open cluster. It's really nice.
Yeah, this is Melot 25.
Mhm.
This is NGC 1647.
Mhm.
Hmm. Don't the white spots in the sky that are stars come in different sizes anyway?
They do, but the size you see them is not representative of the size they are.
Oh, I see. Yeah.
Your eye sees them as big because they're bright,
Mhm.
just like is shown on the star chart here. Remember, you can't resolve any of these stars in an amateur telescope.
Well, Betelgeuse is what, 600 light years away, and it's a monster.
Yeah,
Mhm.
So
we
it's
can
another-
resolve that with some of the really big telescopes,
Mhm.
but
Really?
mostly we can reconstruct an image of it through interferometry and with radio telescopes.
Huh. Well, if Betelgeuse has exploded by now, is the hardcore stuff following the light waves and going to hit us after we see the?
The light waves will get here first. We may never get the hardcore stuff.
Oh, okay.
Tom,
It's
is it
way
16,
too far for that.
Hey, Tom, is 1647? Is it it's a cluster, but how many stars in that cluster? A lot or just a few?
No, not a lot. It's pretty patterns. I've seen it in the 8-inch when I dropped the power down at Westmont. I've seen it in my f3.6, 8-inch scope at home.
Oh, okay. Okay, so that's going to be a good target for us.
Yeah, you can get a sense of the area of it too. See, compared
Yeah,
the Hyades is just explosively big, and this is, pretty big.
Yeah, okay.
I'm not up to date on Hyades. Is that a star cluster?
Yes.
Mhm.
Okay, and that's
Probably
what
the
we're looking
most studied star cluster.
Yeah.
It's the
it's
closest open to us, isn't it?
That's right.
I
That's
think
right.
so.
Mhm.
It's also it's also prominent in that Iroquois myth of Pleiades.
Yeah.
Mhm.
Huh.
Yeah.
So this on the column on the either side, you can see that this is about 13.5 degrees of positive declination.
Mhm.
And the top of this is just under 20. So it's about seven degrees across here.
Holy cow!
6.5. So your telescope, a small telescope, its field of view will be about 1 degree, which will be a
Yeah.
circle about like this.
Yeah.
So it takes a very wide angle scope or making a mosaic out of images to get the whole cluster.
And
Or
Jerry,
nice
it's
binoculars.
spectacular in binoculars.
Yeah, it's a
absolutely
binocular object if there ever was one.
spectacular.
There's some nice color contrast and some nice
Mhm.
doubles.
Mhm.
Well, if our full moon appeared in that picture, it would be the size of that yellow circle, wouldn't it?
That's just about right. Yeah, that's about half
Yeah.
a degree across.
Okay.
One of our members, Andre, has 3D printed pair of binoculars. He comes to a lot of these outreaches. They are just fabulous. I took a look at the Pleiades through that, and I don't know how he did it, but it gives a 3D look at these star clusters, pulls them in really, really great.
Are these the ones he built, Tim?
Yes, yes.
Yeah, okay.
Now, Tom mentioned looking at it through the 8-inch at Westmont College. Westmont College has two telescopes, a Ritchie-Chrétien, I believe, 24 inches or 20 inches?
24-inch RC.
And on the side, it has an absolutely outstanding 8-inch 3-element apochromatic refractor, which in itself gives stunning views of planets when the scene is steady, which it can get there. Who made that scope? Was that a Thomas Back?
Tech. They call it the Tech Scope.
Okay.
TCH.
That's the company that made it?
I think it's TEC.
Oh, that's who made it, Chuck?
That's it, TEC.
Okay.
Yep.
Yeah, it's absolutely outstanding.
It's an F8. It's an F8, Jerry. So, it's kind of a squeezed view. But if you put like a 35 millimeter on the front end of on the eyepiece end, it's pretty neat.
Yeah, I've looked through that.
In fact, I think that's what we use most of the time for the public.
Yeah.
It's fabulous.
It's easier to get at the eyepiece.
Yeah.
This is an amateur picture of Comet 144P Kushida.
Okay.
This was taken on January 16 of 2009.
Wow.
It is a periodic comet, and it's revisiting us again.
Okay.
I just read an article on why the cores of comets are green. And
atomic carbon.
yes, that's right. It's a form of carbon that is very unstable, and it immediately reacts with any oxygen around. It's called dicarbon.
Well, I always thought you could tell a comet immediately in your scope by the tail, but this one looks like a star. You'd have to watch it move, wouldn't you?
That's right.
Stumbled upon it.
Plus, it's fuzzy. A star generally is more pinpoint.
Yeah.
Yeah.
As this thing gets closer to the sun, it will have more of a tail. If it's
Ron, when a lot of times we'll spot these comets in our scopes, and it'll look just like this, except a little bit more dim, but it has that fuzzy outer shell there.
Well, answer me this. Just like there's two words, one of them is opposition to planets, whether they're on the other side of the sun or not. Are there words that apply to comets that would mean it's in coming in phase or going out phase? Do you understand my question? These comets, are they coming in for their whip around the sun, or are they going out?
It's inbound and outbound.
So this one's outbound. It's already passed.
Oh no, they're periodic. I don't know what the photograph taken in 2009 represents, whether it's incoming or outgoing. But they've been around a number of times. They're come around again. That was 2009. That was 15 years ago. Depending on the period, this could be either way.
But if they come from the Kuiper belt or the Oort cloud, they definitely have a parabolic or elliptical orbit.
That's true, but that doesn't really narrow it down very much.
Yeah, all comets have parabolic orbits, pretty much.
You'd think there would be a word that keep hearing, like this planet is in opposition. Well, which situation is
the phrase you hear with comets is it's nearing perihelion.
Yeah.
Oh, it's perihelion.
That's it's close to the sun.
I think Ron is talking about like the ingress and egress, and that would be more like something traveling across the face of a planet.
Historically, what comet has come the closest to the Earth? Do we know? Halley's?
I don't know. Halley's did come close, but not close that it was going to hit, but it came close in the 1800s or the early 1900s. What is it,
1910 or whatever it was.
Yeah, that we passed through the tail of it.
It could be Tunguska would be your record holder there.
But they could come in from any direction. They're not necessarily on the ecliptic, are they?
That is correct.
Wow. Taking a call.
I'm going to unmute myself.
Okay, so this is a chart of comet pan stars.
Mhm.
Crossing near the it will cross through the coat on March. At the end of March, it will pass through the coat hanger cluster.
All right.
Coat hanger.
Yeah, the coat hanger. Now, this is where it is right now. This is Alpha Scorpio.
Antares.
Yeah, Antares. And this is the claw end of Scorpius. And the teapot part of Sagittarius is right here. So this is well placed in the morning sky. The comet won't be there in the summer when these things are in the evening, but it's a good shot right now.
And it's discovered 3 years ago, according to that number.
Yes.
Jerry, what's the magnitude of that?
Right now it's 8.3.
8.3. Okay.
None of these are naked eye comets right now. One
That's the coat hanger.
Yeah. This is just a picture of the coat hanger cluster.
Ah,
This
I
is the
see.
part you put
Yeah.
your shirt shoulders on, and there's the hook that goes over the top.
Sometimes called Brocky's cluster, or I
Uh-huh.
think it's a colander 299, I think something like that.
I don't
It's a
remember the
colander.
number.
Yeah.
So it's not only an asterism, it's a star cluster?
I think it's just an
Just
asterism.
an asterism, right?
Asterism.
Just a bunch of
This-
stars that's shaped like, okay, got it.
Mhm.
This
Amazing.
was taken by an amateur, Jose J. Chambo of Valencia, Spain.
Hmm.
And he did it in a GSO 8-inch f3.8.
Yeah, pretty
And
fast.
this is between Scorpio and Sagittarius?
Yeah.
No,
I think it's up in Vulpecula, isn't it,
Yeah.
Chuck? Yeah.
It's what?
it's in
Up in
Vulpecula.
Vulpecula, the Fox. So it's a summer gig. It's the
Yeah.
thing.
So this is
in the
okay. So
summertime.
where is it with respect to this chart? Is it up
Nowhere near that.
Nowhere near. Yeah. Tim, this is a chart of where the comet is today,
Yeah.
but in the future, it will be passing through the coat hanger cluster.
Right.
Okay.
That's it.
Oh, okay. Okay.
I should have put that on a map. Okay. So this is Comet 12P Pons Brooks.
Uh,
It is passing
This-
through.
This one might get quite bright.
Oh, Alpharet. There's Alpharets.
Mm-hmm.
and it's green.
And Mirach right there. That's what near M30 and near Andromeda.
Yeah.
So the line ends
yeah.
at the left on the screen, therefore it's heading to
Mhm.
the left, isn't it? Moving that direction.
Yeah, it's going this way. It's right after sunset. So it's an
Mhm.
early
Pretty
evening
low.
object.
Pretty low now.
Yeah.
Wow.
It's got to hurry up. And this is a picture of that comet taken on January 14,
Okay.
2024, with just a 700D DSLR camera.
Mm-hmm.
Really weird color balance.
Yeah,
Yeah.
it's not well processed. This is the comet here.
Right. Little
Mhm.
green
You
spot.
can see the green fuzz around it. Of course, you
Holy
can see green
comets.
fuzz around a lot of stuff, but yeah.
Only comets appear green in the sky.
No.
Mm-mm.
Well, everything else is either red dwarfs or
There are no green stars in the sky. Let's put it that
Right.
way. Even though it's the color we're most sensitive to in our eyes, but this is very faint color light. There is one star that would claim to be a green star for a long time, and it was the Pup, the small white dwarf connected to Sirius, the star. And it was later decided when I was a kid that it looked green by contrast with the, I think it was the Sirius. It might be, oh no, it was Antares.
Yeah.
Antares minor star.
Oh,
Correct.
okay.
Because it
And,
looked green by contrast.
Yeah, that's a
One
tough
of the
one.
doubles in Hercules also had the reputation that one was green.
That's right. Yeah. Yeah, the star near Antares is a real tough one. I've seen it up in San Jose at the observatory that we built.
Mhm.
Yeah, it's tough. That's a tough one.
Recently, it was quite gettable because the moon occulted Antares in the early
Okay.
morning
Yeah.
sky. And if you watch the emergence, the companion star popped out first, so you got a
Yeah.
chance to see it easily.
Wow.
Interesting.
For a moment.
Yeah,
makes you wonder why we
Now-
started making all extraterrestrial aliens green. Where did that come from? Ron?
Well, Ron, planetary nebulae look quite green too. That's why they're
Green.
called that.
Green's my favorite color. It's the color of my lawn, my yard, finally, in the rain. Okay, where are we now in space?
This is a picture of Comet Atlas, Tsushin Shan, and it's not in your talking points I sent out. I forgot to include it, but this is it. It's Comet Atlas. This was taken on, what's that?
It is listed. It's the last listed one. So
yeah, it's
apparently
listed, but the photograph isn't in there.
okay, but the Chinese got to find two of these then and put the same name on it, or the same astronomer in China, I guess.
That's their observatory, Ron. It means Purple Mountain.
Right.
Oh, that's where they, okay.
This one is the one that is, this is in M44 right now. It is supposed to reach perihelion, swing through perihelion on 27 September 2024, and is best seen from the northern hemisphere in the early evening, October sky. It may possibly become a naked eye spectacle, according to Astronomy Magazine.
Okay, fix me up with perihelion again. What does that mean?
Closest to the sun.
Oh, so it's coming in.
Yeah.
On its way in, all right.
Whenever you see helion in something, it's like Helios, the Greek name for the sun.
Okay, but I don't know what what would be the opposite of perihelion?
Aphelion.
Aphelion?
Aphelion.
That's when we lose sight of it later and it's way out in the Oort cloud and too small to see, I guess.
But with amateur scopes, yes. Halley's is just, I guess a month ago it turned around and it's now heading back into the inner solar system. but it can still be photographed with a large observatory.
So we can track Halley clear out there, right?
Yes.
In the shell. Wow.
No, it's out by Neptune.
Oh, that's what's inside. Okay. What is this? A double? No, what is it?
It's the rubber ducky.
Rubber ducky. This is an extra bonus. It's not one of the 5 that's up in the sky right now for us to see. It may be up there, but it's too faint. This comet Churyumov-Gerasimenko. And it was photographed by the Rosetta spacecraft.
Wow.
This is the one that they had the lander on.
Yeah. And you can see all the crap coming off that is being thrown into space, all the volatile material that's boiling off in the sunlight and is going off into space to make a tail.
Well, are they connected, those two balls?
They are, but whether they have any tensile strength, I mean, they might come apart easy. They might just be leaning on each other.
Okay.
But that's why it was called the rubber ducky, because it had the head and the body.
I swear I've seen this in a horror movie or a science fiction flick somewhere or something like this.
See it at the star parties. Chuck always goes, "Don't drop it, or your feet will look like a duck."
Yeah.
You ever seen Chuck's feet? He looks like a duck. He dropped it a couple of times.
Oh, this I was going to ask you, Jerry. The one to the right is the heart.
To the left is the heart.
Left is the heart.
Huh.
Heart and soul, I fell in love with you, heart and soul. It's the one we play on the piano, isn't it?
Yeah. 1805. These are IC 1805 and IC 1848. They're two huge emission nebulae in the constellation Cassiopeia, the Queen. They are 6,000 light years away and together span roughly 300 light years across.
Oh, wow.
Tim, another name I've heard for that heart nebula there on the left that I think is actually better is the fish mouth.
Fish mouth.
I've never heard that.
Yeah.
But I see what you mean. Yeah.
You need a hook asterism right on top of it.
So 1805 is the heart.
Left is the heart, the 1805. Right is the Soul Nebula, IC 1848.
1848. Thank you.
Just in time for Wednesday.
I'm not aware of if these are really visual objects. They're certainly photographed well.
I think they're pretty dim visually.
Yeah.
Oh, too bad. I was gonna go try.
No, don't let me stop you.
Yeah.
Oh, okay.
Especially if it's a good night, give it a shot.
Yeah.
Yeah, why not? Why not?
Apparently, we've lost Bruce. He went to answer that phone call, I guess.
It answered him.
So these are okay. Those were Heart and Soul are both nebulae. They're
Both
not
emission nebula. These are things where gas has come together. These are not the product of an immediate spewing out from a star. They are spewing out from stars a long time ago, but now through turbulence and gravity, they're starting to coalesce into clumps. And inside those clumps are dark spots, dark nebula concentrations, where gravity is pulling them together to form accretion disks or stellar accretion or planet solar systems. So it's a
Right.
very early stage. They will be replaced by, they probably have in them each one the start of a star cluster. And eventually that gas will be blown away and there will be just the star cluster left. It looks like there's a star cluster forming right there.
okay. Did you explain and I
Right
missed
there.
why one's a certain color, yellow, and the other's red?
That is difficult to discuss because we don't know exactly how the guy processed them. And you got it, and all the colors you see in these images are all false color. So it's a judgment call by the processor.
So you won't see that in your scopes.
You might, it depends. You won't see the color in your scope, I guarantee you that.
You could
Another-
certainly say that the one up the Soul cluster would probably be a lot of hydrogen in there, and the other one looks like it has some greenish in it, so it might have some oxygen mixed in there.
Possibly. I would
There's
have
a
to
lot of-
look at other photographs to see if this color rendition is unique or not.
There's a lot of pink out there in space, isn't there?
Red,
That's fluorescing hydrogen.
yeah.
I don't know why that heart one to me looks like a pretzel.
Yeah.
Well, that does that too.
Okay,
Okay.
fantastic.
This is the Sagittarius
The
asterism,
teapot.
the teapot asterism.
Okay.
This is the early morning sky.
Mm-hmm.
We had something similar to this last week.
Yeah, because
Yes.
you see Venus to
Yeah.
the left there. Yeah.
Yeah, Venus is up there. Venus is about to become an evening object
Mhm.
in about another month and a half.
Right.
You can see this is of course not a picture. This is a graphic on a planetarium software.
And Jerry, on the 22nd, it's going to be pretty close to Mars, Venus.
Okay.
Okay.
Do we have Mars on here?
There it is.
Oh yeah, there it is.
There's
Yeah.
Mars, Pluto, Venus, and up here is Saturn.
Mhm.
Holy boy.
So everything's hanging around the galactic center here.
Yeah.
It's not really, it's just in the way when you look to the galactic center.
Yeah,
You
and
know, you were
center's
mentioning
right
you didn't like this display as much with this software. It looks like it's simulating fuzzy seeing.
Yeah. Yeah, I've got to learn. I'm not in as good a control. There are some features I can't find on that because it really changed it between 6 and X.
Mhm.
So this
What-
shows a lot of features here coming up out of the teapot,
Mhm.
the steam. And of course, this is the core of the Milky Way where our galaxy core is.
Mhm.
And this is a photograph of that region
Mhm.
taken by John Murph and posted to Flickr. So the teapot is in here somewhere.
Mhm. You can see
Oh,
the
there it
hand-
is. I see it.
Yeah.
Yeah.
Yeah, there, right there and there.
And so this spout is right where your cursor is, just to the right of that.
Yeah,
There's
right,
the tip of the spout, and
Yeah.
so the
Yeah.
center of the galaxy is right in there.
yeah, right up
You
in
can
here.
you can also see the southern crown down in the lower left.
This, oh,
Yeah.
left.
Yeah, there's the crown.
This,
Or Chuck says it's a lemon, a lemon slice.
Yeah, you got the teapot, you've got a teaspoon, and you've got a slice of lemon. So you have the whole
Yeah.
tea party there in the
Huh.
sky.
I never saw that teaspoon.
I didn't
That's in
either.
there.
Yeah.
Teaspoon
this
is up in the upper left. You can just see the bowl of the teaspoon there, but the handle goes up out of the screen on the upper
Right.
left.
Oh, okay.
Huh,
And the Lagoon Nebula is right there. Yeah, showing up
Mhm.
whitish.
yeah. And this one,
I don't, that might be
Swan?
Trifid?
Trifid,
terrific.
Okay.
Yeah.
yeah.
Perfect. Day of the Triffids. Remember that
Yeah.
horror movie?
Mhm.
Yeah. And then up
Book was
above,
better.
That was
up
one of
above
the,
is going to be the Swan Nebula, but it's
Yeah.
just out of the picture, I believe.
Mhm.
So I'm just going to mention, Tim, a fun challenge here. Jerry, if you put your cursor at the very tip of the teapot before you pour out, right there, a really cool challenge in an 8-inch is there's a pair of globular clusters, of course, way the heck in the distance, just to the right of that. And it's always a fun thing on a summer night to try to knock that thing back right in
just
there.
to the right, like, right there.
Yeah. I forget their numbers.
Yeah.
They're NGCs. They're NGCs, but it's real neat.
Yeah, Tom, we went after that at
Yeah.
Antonio and
Mhm.
got him.
Yeah. In an 8-inch, you can get them.
Yep.
And then, of course, all of these dark areas where there's missing stars are not missing stars. These are clouds of dust and gas that are in the way that block our view of these star clouds. But the star clouds themselves are continuous.
So, Jerry,
There's-
if you put your cursor just to
Yeah.
the right of where you are, down, right, a little bit lower, a little bit, right there. I call that the horse, but people call that
Oh, yeah. It looks like an
the
elephant
pipe.
to me.
People call it
Oh,
the pipe.
it's
Yeah.
got yeah.
I
Somewhere
always
in
say
there is
little
the
horse.
ink spot too.
Yeah.
The ink spot's fabulous. It's just
Yeah.
I've tried to get that again and again, but
Yeah.
it-
Joe likes that one,
Yeah.
the ink spot. Joe Doyle.
Yeah, this is
Yeah.
a interesting stuff. This will be up in the evening, in the warm evenings, in the
Mhm.
summertime from here.
yeah.
And it's a wonderful area just to explore. You point your telescope anywhere in this region and you're going to find something interesting.
Yeah.
That's right. That's right.
But would it be fair to say, gentlemen, if there are extraterrestrial cultures out there on other exoplanets, they all have a swath in the sky like we do, but at different angles, probably, right? The center, the Milky Way.
If they're in
Yes.
our galaxy.
Yeah, well, that's what I'm talking about. But this dust cloud we're talking about that we all see on the sky, does it go clear around the Earth?
Yeah. Oh, no, around the Earth, no.
It disappears somewhere.
Well,
But
it
if
goes
you-
completely around the center of the galaxy, which is right here.
Mhm.
It goes around that and wraps away. But we are 2/3 of the way from the center to the edge.
Right.
And so
Right.
there's the thin part of the disk that's, when we look at the center of the thing, there's the thin part of the disk that's behind our head.
Mhm.
So we're
But-
in the midst of it. When you read old science fiction books and they talk about being on a rim world, that means a world on the rim of the galaxy. Well,
Right.
we're a rim world. Our sun is on the rim of the galaxy.
And Ron, the Milky Way does go in a circle all the way around us.
Yes.
Well, we're okay, but if it would be worse if we were in closer to the center, right? We'd see a lot around us. We probably
It would
would
be brighter all around. Yeah.
Yeah.
Would
And
it
if
be?
we were at the center, we'd see this everywhere.
We'd be in danger of the big black hole too.
Oh, we would be wiped out with radiation. The
Oh,
galaxy
okay.
is not a happy place for human life.
But the reason
cool
it's at
thing-
the reason it's at that angle is that our solar system is tilted, and every star's stellar system has a different angle. Or are we all on the? They all see it the same angle as we do in the sky.
They're all different. They're all different.
All different. Okay.
There's a question you once asked about, are all the galaxies out there that we can see that are flat disks, are they all flat in the same way?
Hmm.
Do they all have a certain
A plane.
a plane? Yes, certain plane. There is a active research project looking at that, because the reason they're looking at it is they're trying to see if there's any evidence that the universe itself has a net angular momentum, or had at one time a rotation, and it would have broken up through eddies and back spinning. It would have broken up into small eddies that became the galaxies. So I don't know any results from that.
And a cool thing, Ron, coming up in May, you don't see the Milky Way because it goes right around the horizon.
Right.
From our point of view. And
Oh.
that's why it's galaxy hunting time. That's why people go and hunt the Virgo cluster and other things, because you don't have all this stuff getting in your way and you can look out to other galaxies.
Oh, how interesting.
Yeah. When Chuck says that we see this all the way around the sky, we do, but the really bright stuff is in here. And the stuff that's 180 degrees out from that is still there, but it's dimmer.
Yeah.
But Southern Hemisphere sees it in a different place, but still at an angle, right?
I don't know what you mean by different
Yeah.
place. Yeah.
Well, aren't we? We're in the north. They're down in the south. That's
Yeah, they'll see a different part that we don't see. There's some of it we see in common, and then there's things up here that they don't see.
Wow, fascinating stuff. All right, sunspots are us.
This is a big sunspot coming around the rise. So this is a poses a threat for strong X-class solar flares.
Yeah.
And we'll get to that in just a minute. This is the sunspot when it first came out. This is a picture taken on February 4th.
Yeah, we saw it last week, Jerry, in my refractor, of course, safely.
Uh-huh.
Is that
Yeah,
the
there
one
it
they're
is.
calling the Mars
It's a
sunspot?
huge group. It's a
Yes.
huge group.
Yes, this was imaged by the Perseverance rover on Mars. It's so big.
Really?
This
And
is a
if you go to spaceweather.com, there's a map of the magnetic fields of where the positive and negative cores are, and it's really complicated.
yeah.
Yeah. Yeah.
So
That's an amazingly big group.
Perseverance
This
saw
is
it
4
before
days
we-
later on February 8th.
Mhm.
Wow. And that's a monster that can cause us problems.
The classification for flares uses the letters A, B, C, M, or X. And this is measured according to the peak outflux in watts per square centimeter. That's a flux density of soft X-rays, not visible light, but soft X-rays between wavelengths of 1/10 to 8/10 nanometers. For you older people that are calibrated in angstroms like I was, it's 1 to 8 angstroms of wavelength, as that's very short wavelength. Visible light is in the thousands of angstroms.
Mhm. Mhm.
And this is as measured by the instruments on the GOES satellite in synchronous orbit. So it's not measured from Earth. So this is the output flux measured for different classes of stars or of flares. And
Wow.
the way
It's
to
watts to meters squared or mass squared?
meters
Meters.
squared
okay.
per square area from
So yeah. So it's power, Tim, over area.
yes,
Oh, okay. Thank you.
it's a power density.
Mhm.
So an X2 flare, and now in the X category,
Mhm.
an X2 flare is twice the strength of an X1 flare. It goes up between 1 and 10. An X3 flare is 3 times as powerful as an X1. So an X2 is 4 times more powerful than an M5, for example. Anyway, without seeing the chart, it would be odd or hard to do. So let's get to that. This shows an M5.8, M2.3, and an X2.8 flare that were recorded by GOES 16 on 14 December 2023.
Huh.
So this is a, you think this is like twice that, but these are powers of 10 scale here. So to get from here to here is a big jump. This is a log scale.
Can you clarify something about the 22-year cycle for me? 11 of those
22?
years, they're getting worse, and we see more of them until they peak, and then they go down to nothing. And where are
It's
we on
11 years from peak to peak from our point of view.
11 years? No, I thought it was 22 years. 11.
It's 22, but one peak has one polarity and the next peak has another polarity. So it's
Well, see,
actually a 22-year cycle, but from our point of view at first, it looked like only an 11-year cycle.
Yes,
But
what
my
happens
point
is the sun has a magnetic field,
Right.
and in 11 years, it twists up. until it sort of snaps and then it reverses. And then it twists up till it snaps and reverses again.
Okay, so
So
my question involves what we're looking at right here. Is this the point of
no,
twisting?
this is during, these are things during the peak solar an active solar period.
Ron, this is something that's happening over one day.
Yeah.
This chart you're looking at.
Mhm.
Okay, somebody tracks these things, and this just
Oh yeah,
happens to
several
be
of
bad.
them do.
Okay.
Especially our military. This thing can really play havoc with Earth.
Mhm.
All your GPS can go out. All your cell phones can go out.
Mhm.
So was it recently?
If you're still using a Morse code thing, you can get your fingers burned.
Oh, jeez. Wow. What's the difference between the red line and the blue line?
Different wavelengths. You see the chart up at the top there?
Yeah, that's right.
Oh, okay.
The red line is longer wavelength than the blue line.
Mhm.
So would the red line be like infrared and the blue line be like ultraviolet or something?
No, they're both way in the ultraviolet.
Oh, they are.
They are, yeah. What did they characterize them
They're
as?
an X-ray. Yeah.
Yeah, soft X-rays. Yeah, that's right. Soft X-rays.
Soft X-ray. We get X-rays from the sun.
That's
Yeah.
it. These are the X-rays from the sun.
Yeah.
Okay. Are gamma rays worse? They're in the
Yeah,
same
gamma
ball.
rays are hard X-rays. They're shorter wavelength. They're more energetic. They're more
Oh, I
damaging.
see. The very top of the scale.
Yeah.
Wow. Well, has it affected us? Has it hurt us?
This particular time, no, everybody's kind of, getting ready to block a thing. So far, it has not produced a coronal mass ejection. But these are the types of situations that do sometimes produce a coronal mass ejection.
I think it did produce one while it was still coming around.
Okay.
And the rotation of the sun brought part of it so that it hit, and it blocked out shortwave communication, I think, in Antarctica.
Mhm.
Okay. We got 3 minutes, so I want to ask my stupid, silly question that's been occurring to me over the last few weeks about sun. I heard that the fusion takes place in the middle, right? The hydrogen becoming helium.
Yeah.
What are we seeing then out there on the surface if it's not fusion, or what are we seeing? Something very bright. It's
You're
not
seeing heat that comes up.
just heat. We're not watching any process.
If you put a pan of oil or grease on your stove and you turn the flame on underneath the pan, you see the bottom of the pan gets hot and the top of the grease starts to boil. And what you see is the heat coming up from the source down below.
Mhm.
It's analogous to that.
Mhm.
Huh.
Ron, if you were seeing the fusion, it would be horrendously bright. Well, it would be in wavelengths you couldn't see. It would be gamma rays. It'd be all gamma rays. Okay. But they have to pass through all these layers and layers and layers of sun.
Right.
And each time they're absorbed and re-emitted,
Mhm.
they can get, like one gamma ray can suddenly turn into 3 photons of different wavelengths
Mhm.
as they get re-emitted. So it's gradually, you can think of it as cooling as it comes out. And eventually, when it reaches the surface, these photons get released mostly as visible light.
Right.
In a temperature range that looks to us like the sun's brightness.
Right.
Yeah, the core of the sun's temperature is over 10 million degrees. The surface is at 5,800 degrees Kelvin.
Right. Right. And Ron, I was just going to say that when, we look at the sun, like Jerry says, it's 5,800 kelvins. Basically, we only see, because the sun below is opaque, we only see about a couple of 100 kilometers, from the surface down in. That's it. You don't see the fusion furnace going at all. Well, plus, like Chuck said, those are gamma rays anyway. So
what you're painting a picture of, gentlemen, is something like a lamp. The lamp shade is what we're looking at. In the middle is the light bulb that it would blind us.
Exactly.
yeah.
Exactly.
Mhm.
Now,
Okay.
this is a picture of AR 3756 taken by Christopher Go on February 9 of this year.
He does incredible stuff.
Yes, he
Yeah,
does.
wow.
This is extremely good resolution.
Yeah.
Except why do you suppose it's black inside a one of these.
You're seeing temperature differences. The black is
Right.
slightly cooler than this, and the patterns you see are due to the magnetic fields.
Oh,
Ron, if you had a sunspot all by itself in the sky without the rest of the sun, it would be brighter than the full moon.
Yeah.
Right.
well, do you suppose our own Earth's magnetic field does the same thing? Does it twist up?
No.
It doesn't. Okay.
It looks like a bar magnet.
Yeah.
Yeah.
We're not a fluid body the way the sun is.
Right.
Well, I got lots of questions.
We're a plastic body. We have very highly viscous fluid.
Well, we don't have time to answer all the questions I have about magnetism, the difference between north and south and plus and minus and positive and negative. Apparently there's some differences, but we'll save it for the future, I guess, gentlemen.
Okay, we'll do magnetism next week.
Okay,
Oh, boy, that'd be great. That'd be
all
great.
righty. We got a little less than 3 weeks before our big meeting with Bob Berman on the screen, the columnist for Astronomy Magazine, and I hope that goes well. And we miss Bruce. He's got a reason for having left us, but let's do it again next week as we head for year number 4 of the Astro Hour. Gentlemen, take care of yourselves and your wives.
Thank you.
Thank you, Ron.
Thank you for teaching.